Hello everyone and welcome back to another Math Inventors YouTube video. And this video is going to be over what are variables. So now I realized that after I made the expressions video that some of you guys may have had some confusions, I guess, over you guys may have gone to the process where you might have been confused why I'm using letters like X, Y, and Z and all them. So this video is to clear out that confusion that you guys may have had having. I'm not saying you guys would have been having that, but I feel like let's specify on it. So now let's take a look. So like in the last video on expressions, I did something like 2x and all that stuff, right? And then I had a letter X. So now this X isn't literally like just your X or like your alphabet X. It's not the same thing. It's different. This one, and as you can also see, it's also written differently, right? It has the cursive kind of thing to it. So if you see this in a math statement, that doesn't usually mean multiply, because this also stands for multiply. This stands for a variable. Now, what's a variable? It's kind of in the name. You know, if you know the meaning of the word vary, it means that it can change. So, like, just take a look at this. So let's say I have this equation: 2x plus 5 equals, say 9, right? So now in this case, if you were to try different values for x, you can see that x is equal to 2. But I can have another equation, x plus 4 equals to 5, where you can clearly see x is equal to 1. So the values can keep changing. That's why it's a variable. Keeps changing. But if you find out the value for it in one equation, and if you try substituting it in the same equation, it'll say same throughout for that one equation. Alright, so now let's look at a more deeper explanation of variables. Now just take a look at this. For example, you have a fill in the blanks math statement, and let's start small. Say 3 plus an unknown value, let's just say an underline so you guys have a blank, is equal to 5. Now, yes, clearly we can see this is 2. We all realize. But instead of just putting a blank there, you can also do this. 3 plus x equals to 5. It's still the same placeholder. They're interchangeable. Both can be used as variable. This green underline or blank can also be used as a variable. Alright, so you guys have been working with variables. You just didn't realize it. Alright, so now let's look at how we can solve these variables or equations without using just substitution. And substitution is when you take a value and you replace it with the variable. So if I were to substitute or replace the variable with 2, that will make 3 plus 2 equals to 5, which means 5 is equal to 5, and that is a true statement. And this is a way you can cross-check, but we'll go over this more later in the current video. Alright, so let's see. Say you have, I'd say x plus 9 is equal to 16. Yes, we know x is equal to 7. So let's just write it down to the side. But let's solve it. What if we were to solve it? How can you solve this? First step is to isolate the variable. Like, leave this variable x alone on one side of the equal sign. It's already on one side, so what we have to do mainly is get rid of this 9. Let me underline it in blue. We have to get rid of this 9. How do we get rid of this 9? Well, it's simple. Take a look at it like this. If you have positive 9 and you want to get to 0, how can you do that? Well, if you take negative 9 away from it, you get 0, right? So if we just subtract both sides by 9, like this, we'll have x alone And then 16 minus I is 7. Here we can also see that also results in x equals 7. It's the same answer, right? So these are just two different methods you can use. And these are just simple right now one-step equations. But as you get close to bigger equations like two-step and multi-step equations, just substituting random values will not always be the most efficient method. You're gonna need to know these methods that I'm explaining right now. Alright, so let's take a look at another scenario. Let's do it in yellow. So now, say I had x minus 3 equals to 6. Everyone knows x is equal to 9. Keeping it off to the side here. And let's solve it in red. Using the method I told you, you just need to do a thing called inverse operations. Let's write it down right here. Inverse operations. Alright, so now inverse operations are basically operations like addition, subtraction, and division, multiplication. These are your four operations. And what inverse means, you can think of inverse as undo. Just undo. Okay. So now thinking back, we can just say plus, like adding and subtracting. These are inverse. This is an inverse operation. And multiplying and dividing, these are also inverse operations. Okay? So now looking at this, and if we were to apply to this, we can see we have a subtraction case. So to isolate the variable, what do we need to do? We need to add, right? Because it's an inverse operation. So that means we add 3 to both sides like this. And this is not required, plus 3. That gives x alone on this side. That's equal to 9. And would you look at that? It's the same answer again. So now, let's look at a multiplication scenario. Or before we move on to multiplication, actually, let's save that multiplication and division for next video, actually. How about let's do a different scenario of regular addition and subtraction. Now, every time I put x in the starting, but let's see a scenario where x is in the middle of somewhere. Say we have 16. X is equal to 11. Now we can easily tell x is equal to 5. No doubt. I agree. But let's solve it in yellow. And of course, we want to isolate the variable. So now this is like, there are two methods where you can do this. So I'm going to show you both methods and you guys can just choose doing it however you want. But one method requires a little multiplication, so if you want, you can just use the other method. It'll take 2 steps in the other method, but no worries. So the first easier method is to first make the x variable. Since it's a negative and we need a positive x, right? There's no negative value in this answer. So that's why we'll add x to both sides, which gives us 16 is equal to 11 plus x. You can also rewrite this just as x plus 11 is 16. Both are the same thing. Both mean the same, so don't worry. And now, using inverse operations, if I subtract 11 on both sides, we'll get x is equal to 5. Same answer. Now, let's look at the other method. Hold on, give me a minute. So now we have this method. Now let's solve the other method in green. So now, if we go with our isolating the variable policy, we're going to have to subtract 16 because this is a positive right there. So subtracting 16 from both sides. Hopefully you guys know how to use your negative numbers. If you don't, I'm going to have another video over how to use negative numbers in multiplying, adding, dividing, and subtracting, but just go along with me for this video. So 16 minus 16 is going to give us 0, so that leaves us with negative x on this side. And 11 minus 16 is just the same thing as 16 minus 11 with a negative sign. So 16 minus 11 is 5, and then add a negative sign to it, you get negative x is equal to negative 5. And if you were to divide or multiply both sides by negative 1, you get x is equal to 5. And don't worry, I get it. You guys may have a little bit of confusion on how I got this answer from negative x to positive x. And as I mentioned before, I will have another video over it. So now I'm going to give you guys one bonus problem. One question to solve on your own. And then a bonus problem. And that will be the end of our video. So the one question I want you guys to solve is x plus 3 is equal to 11 minus 2. And you just need to simplify the 11 minus 2 and then solve. And the bonus in red. I'm going to say x plus 3 is equal to, or actually instead of 3, let's make that 8, is equal to 2x plus 5. And don't worry guys, I will also have another video over how to solve these. But this is just to test whether you guys will get it or not, alright? So thank you guys for watching another video of Math Inventors. This is Sarthak from Math Inventors.